Bill Chestnut. Good. How are you? Hey, James, are you there? Hey, James, can you hear me? Hello, everyone. We're just having a few technical difficulties on this at the moment. We will be joining here shortly, so just bear with us. everyone just bear with us a moment. James is having some technical issues with his laptop and just rebooting. So we'll be getting started shortly. Just to let you folks know that we will be getting started shortly. James is just having an issue with his laptop. So just a question while we're waiting for James to join back in. He's having an issue with his laptop. So how has the audio and video been on the previous two talks? So we're just waiting for James to dial back in. He was having an issue with his laptop. So it shouldn't be too much longer, folks. One thing I will mention is around the Terraform topic from the previous session. I am in the process of downloading and uploading a new a talk from one of my MVP friends in the UK around Terraform for integration services. So I will have that up. It'll be on the same location where the talks from today will be. James, are you here?
Hey there, Bill. Sorry, I just had to reboot my laptop. So.
Okay. So you want to try to share your screen?
just give me 1 second. So
Yep.
I'm a Mac user and I was using Windows to connect before, and now I'm having to go back to using my Mac. So I've got to reconnect to a SQL. 1 second, and then I'll go from there.
Yep.
Bear with me. Are we live?
Yes.
Hello, everyone who's connected so far. It's always when you want things to work perfectly that they play up. Probably one of the challenges of live demonstrations, I suppose.
Yes. That's why I've got 2 laptops sitting here at the moment.
All right, let me share my screen. Just make sure that that's all good. Wrong screen.
So have you shared your screen yet?
I will have in about 3.2 seconds. More. Deliveries.
Yes, there we go. I can see your PowerPoint.
Beautiful. Give me 1 minute. I'll make that big as well. All right. There we go. Ready to go. Just so you can see just my screen one.
Yes, your screen looks good from here. I will be monitoring the question and answer panel. So if there's any questions that come up during your talk, I'll be monitoring that. And so without any further ado, let's go ahead and get started. You can introduce yourself, James.
Perfect. So I'd probably like to start by saying thank you to everyone who's tuned in. I know there was a bit of back and forth, obviously, with COVID-19. So people who've got up on a Sunday morning or Saturday morning to watch a boot camp on Azure, it shows a level of dedication, and it's really good to see that level of integration with the community. So today's talk is called Securing My Integrations, and before we dive into it, I suppose we'll go through a little bit of context and who I am. So about me, I'm a consultant. I work in primarily in security and identity, and I started out in the industry in a data center, managing servers. So I focus primarily on securing cloud platforms, and most of the time that would be Azure platform. But I'm passionate about all of them. So if you want to talk to me about, AWS, Alibaba, whatever it is, your mum and dad's cloud that they've built, we'll do that. And you can probably find me around at a large number of Melbourne meetups. So it's really good to get involved, and, you guys showing up today is excellent. So we really appreciate you obviously coming down. So I suppose today's talk is I'd say it's fairly broad, in that it's focused on integration, but integration as a whole is quite secure, right? Inside of the Azure platform, it's actually really secure. So for me, it was quite a difficult topic to say, hey, let's talk about security on the Azure integration platform, because everything's just secure by default, which is really good. So what we're going to talk about today is your security landscape. Obviously, why do you care about security on Azure? We're going to talk about cultivating a hacker mindset and how to approach security when you're building your integrations. So we're actually going to spend a bit of time and say, well, when I build my integrations, this is how I build them in a secure way, or make sure that, I'm thinking about the problems that I can cause myself, right? I'm going to go through my top 5 security problems to keep in your mind, something that, I see coming up quite regularly and all the time. We're going to talk about some Azure integrations, security features, and recommended configurations. So, covering through stuff that you should do at a minimum And then I might demonstrate I'm going to demonstrate some negative behavior using logic apps and Azure SQL. We're going to do some SQL injection and, and discuss how we could fix that sort of scenario. So suppose, why do you care? Now, if you pay attention to the news recently, you probably saw, quite a few delays in shipping or in your orders being shipped from online shopping. And that was actually due to a really, really large breach of toll group, right? Now, there's still estimates as to how much that actually cost. The highest one I've seen at this point in time is about $200 million, right? And that's horrible for toll. I feel really bad for them, and and quite, I feel horrible about it. It's really not great. But the reality is that type of cyber attack, that kind of aggressive push into someone's environment to, destabilize, inflict financial pain, make people's life difficult, or just, for cyber espionage or whatever it is, whatever the purpose is becoming commoditized. So in terms of cybersecurity, you have a large amount of tools these days that actually automate out aggressive or dangerous behavior. So I can, install a tool like Metasploit onto my laptop, and I don't actually have to have detailed knowledge of how security weaknesses work. I can kind of go through and run a bunch of commands and then push those through to a downstream system. And if that system is vulnerable, I'm magically a hacker, and I've spent probably an hour online Googling how to use a security tool. So the lowest hanging fruit in a lot of environments will really become a target for online hacking. Business-wise, right, in Australia, the average breach, it takes almost a year to get detected and remediated on average, and that's out of a report from IBM just come out recently. I know last year the number was higher. It was about 320, and in 2018-17, it was actually over a year in Australia before a breach was detected on average, right? That cost, generally speaking, for the smaller business all the way up to the enterprise is about $3 to $4 million. Depends on who you speak to there and what metrics they're using. So it's not a small concern for a lot of businesses. It actually is really quite important for them to be cyber secure, because there's financial impacts to them at the end of the day. So when you start out on your cybersecurity journey, a lot of places will go, oh, I built my solution and I think it's secure and I've tested it and I can't find any problems. And then they have, an external pen tester come in, or, they run a tool on their environment and it just basically pokes holes everywhere. And one of the reasons that I see that happening all the time is that organizations and implementers, they don't actually think from the start on how do I secure this thing. So they build, for example, a logic app, or they put in a BizTalk server, or they put in a gateway on premise, and they go, well, I put it there and I didn't care about what it was accessing or how it was accessing the thing or what it was doing. And I was really, not aware of all the things that could happen in my environment. So what I recommend to a lot of people these days is to adopt a process. This is very much, quote unquote, thinking like a hacker. Now, a hacker mindset is not actually the same mindset as a cyber criminal mindset. So a cyber criminal will look at something and say, oh, I can break that and I can have monetary advantage. I can have, a reputation advantage. Now, a hacker mindset is actually looking at how you can bend existing systems to your will, right? So, if you go back far enough, you'll hear talk of, phone phreakers, and that was around getting free phone credit. But it wasn't I'm going to do something malicious. It was just, how do I bend this system to my will? So thinking like a hacker is not necessarily thinking like a criminal. And to accurately design for security, you need to do this, right? So when you're going through this process, you need to think in terms of value. Right. So if you're looking at your application, you say, well, I've got an API and it presents out, let's just say, data on data on clothes, right? What's the value of that API? Can I call that and request a t-shirt? What if someone requests it for free? So there's a monetary value. Maybe I'm a really big company, like I'm a Facebook or an ASOS of the world. And there's not only a monetary value in targeting me, but also there's a social value. So everyone knows who ASOS is. And if I've got a clothes, if I've got a hack that lets me have free clothes, I get a really big set of feedback for stealing all the clothes from a really big company. In the cyber criminal world, I'll become, quite famous. Or maybe you're not actually a target per se. Maybe you're someone in the way, right? So, and that's where you talk about position-based attacks or middleman-based attacks, where you have an environment and you sit in front of someone, or for example, Microsoft's a good example of that actually. So Azure as a platform is constantly being pushed and prodded by cyber criminals, because if you get Azure, you get a lot of people on it. Now, Microsoft and all of the cloud vendors have excellent security teams, and they don't have these issues, but that's something to consider when you are thinking like a hacker. So think in terms of value, right? Now, the formal name for threat modeling for hacker think is threat modeling, right? So there's a book up in the right-hand side there. It's by Adam Shostak, and I really recommend reading it. Go on Amazon. I think it's like $30, and just have a look at how to do threat modeling, right? Now, what threat modeling is actually looking at your system as a whole and as components and saying, well, if I do this thing that is, expected or unexpected of me, what's the end result? Right now, if you look online, there's a wide range of methodologies which are all valid and all useful for you to do as a implementer. Me personally, I use the STRIDE method, and that's broken down into 6 different ways. So the first one is S, which is spoofing identity. Basically, can I pretend to be someone else? Then you've got T for tampering with data. Can I modify something in flight? R for repudiation. So can I dispute the results of the data? So in that scenario, maybe I send something to an API. It says, hey, you've got 4 t-shirts. And I can say, no, I've got 3 t-shirts, and change that, the validity of the data as it comes back to me. I is for information disclosure. So maybe someone asks for a t-shirt from an API and they get back t-shirts and pants, and they're not supposed to see the pants or something like that. Denial of service. So can I ruin everyone else's day and make the platform really struggle to serve the other business? And that's obviously a monetary impact for the victim, but not for the cyber criminal. And then the final one is escalation of privilege. So maybe I'm a standard user. I'd like to be an admin. You'll let me, even though I'm not supposed to be an admin, right? So there's a lot of different ways to do threat modeling, and STRIDE's probably the biggest one. And we're actually going to do further in the talk a threat model of a fictitious integration setup that I've got in Azure right now. So, top security concepts. So these are for me. These are my personal 5 security concepts to be aware of when you're building integrations. There's some really good resources online. So if you have a look at OWASP, they've had a project running now for about 10 years, maybe longer. It's referred to as the top 10. Now, it's actually focused on web vulnerabilities in general. So, it covers stuff like cross-site scripting and that sort of problem. However, a lot of the concepts that OWASP have in their top 10 are generic, and they apply across the board. So I'd really recommend going to check that one out. And then also Microsoft has really, really good resources available for people to read up on. All the products are really documented quite well. And that link in the slides there is a white paper. So what resources, a resource you can go and read. It's about 30 pages on just general Azure security. For me, my top 5 is injection. So can you push, especially into an integration, can you push data that's not really supposed to be there? And can I add data that I shouldn't be able to add? Authentication, can I, do something that I shouldn't be able to do? Maybe I can do something as an anonymous user. Logging and monitoring. So I really do believe that should be implemented in all logic apps an integration platform in general. Like if you've got, Azure Monitor plugged into your service bus or your event grid, you really should be doing that. By default, it comes in there. One that a lot of people don't think of is zoning and boundaries. So when you talk about your data and your integrations and how they sit, they're all interconnected. So you might, benefit from looking at how the systems are connected and going, well, should they be connected here, or should that, like, what is the so to speak gate in that fence for this application? So for example, if I was to look at a SQL table structure, maybe I've got 3 tables for SQL, and they've all got a bit of data in there. If I look at that and I have one account that's configured for my connection inside of Azure API, does that connection have too much access? Maybe it should only be able to access one of those tables, or maybe I should have 3 separate connections to do that. And then the final one is repudiation. I always pronounce that wrong, so I apologize now for butchering that word. But you should be allowing your services to mutually validate each other. So perhaps you've got a key vault somewhere where you're signing out your requests, that people can go and look at that, the public key, and go, oh, that's correct. He's signed it with a private key, and I trust that data as it's coming to me. So I mentioned before that the cloud in general is quite secure. Now, I really wanted to dig into this a little bit before we go any further, because some of the stuff we're going to talk about, you might go, oh, that's a bit scary, or that concerns me. But the most important thing is to understand that the Azure platform as a whole, and then generally speaking, not, the majority of the integration services as a whole, are really, really secure. I went and looked at BizTalk vulnerabilities because I haven't looked at those in a while, and I don't think there's been one since about 2014, like a major one CVE in BizTalk itself. It's actually more in the implementation of the service. So as far as that goes, most of the Azure integration platform sits in that PaaS side, right, where the blue bars is what Microsoft's mostly responsible for. So you have data. Now you will see some kind of variations of this where you've got data and implementation, or data and / application. But basically on the PaaS side, you're actually responsible for your data and how you model it and how you design it out. So generally speaking, really, really secure platform, provided you don't configure it badly. I'm going to show you a little bit later something that's been horribly configured, and we'll discuss some of the ways that we could minimize those issues. All right, so we talked before about threat modeling and what that looks like, and what that could look like and what that is. And I'm going to have a look at this platform today. So just bear with me, just click a pen. I'd like a red pen. Okay, so to start this out, the Simpsons fans on the call will know this donut shop. This is Lard Lad Donuts. Now, Lard Lad Donuts has built themselves a nice new website which integrates with, it's built on Azure, and it integrates with their on-premise Baker's donut generator. So they've got a computer somewhere and they can generate a really good donut. And we're using Azure Logic Apps and Azure SQL to kind of plug it all together, and then Azure DevOps to deploy it all, because we're really cool. So where in this system can go wrong, right? So threat modeling is about taking this system and saying, well, where do I start, right? And I generally like to start with the user. So I'm going to start up here, right? I say, well, okay, the user has access to a donut API, and maybe that's by a website here, right? So I haven't drawn the website in this diagram because it's not really needed. But maybe the user logs into a website and they're filling out a form, and that calls a Donuts API. And the Donuts API takes some data and puts it into the database. Maybe they're ordering donuts, right? So I want 3 donuts, and it goes into the database. Now, in that threat model, I've got a couple of things. I say, well, okay, well, the user's got a login because they log into the website. They've got some orders, and they've got some payment details. Maybe they put their credit card in. I say, okay, well, what if the user puts in the wrong username, right? Maybe they're going and saying, I'd like to see my username. I'd like to see my donut orders for my username, and my username is Tom. Now, if they put in their username of Tom, they should get back, oh, you've ordered donuts 4 times. But what if they put in the username of Homer, right? Do they get Homer's data? Are they allowed to see that data? So understanding, well, maybe I shouldn't be having that irresponsible disclosure and pushing that across to the user. Maybe they're doing something like, I'd like to order some donuts, and they want free donuts. Are they able to do something like SQL injection through the Logic app and push in free donuts? I'm going to demonstrate that a little bit later, not in depth, because it's, but enough to get the idea there, right? So maybe they can, do some SQL injection and see and get themselves free donuts, and everyone's going to love free donuts, right? So that's maybe the user. If I've got, for example, if I look at the payments Logic app, maybe I've got the data pulling this way, and then I've got it pushing out to an API. Maybe I've got Stripe up here that handles my payments. Am I pushing the data from here to here securely, right? Perhaps my nasty hacker man can log into Azure, right? Can I see this flow here? Can I look in the data in the Logic app window and see it in flight as it pushes through to Stripe for that payment, right? So maybe my nasty hacker man can look at the window and go, oh, okay, that's not really great to look at the portal, and I can see all this personal information. Perhaps someone can push from here. I'm going, okay, well, rather than try and mess with the entire platform, I can't get into the website. There's no vulnerabilities in it. I can't get into Azure because they've deployed conditional access. I can't see any data I can. But the legacy on-premise environment over here, that's really insecure. And I can hit this device here, which is an admin device. That's really good. Okay, I've got to this point in time. And I know that the admin has a Git SSH key on his device, and I know that he's got some repos, and I can push to Azure DevOps, right? So maybe now I'll log in and I'll say, oh, I've got access to the environment, and I will push a malicious update to the repo. And then Azure DevOps pushes to Azure. And now instead of my payments app sending payments to Stripe, it sends it off to me, and I've made $1 million. I'm very happy with that. So there's a lot of different ways to look at your system, and it's really important about taking each component in its entirety and saying, well, what if I do something wrong, right? And then for every single one of those things you did wrong, how can I fix that? Or how can I account for that? How can I plan for that? And then really understand, well, if someone puts in, the user of Tom puts in Homer's username, can he see the donuts? No. And I do a check for that, and I check that the user that I'm getting is what I'm expecting. Maybe I'm, really concerned about this path here where I'm pushing from the admin device through to a nasty payments API. Maybe I've got a check here to say I would like an approval or disapproval. Or maybe I've got something like the Azure Secure DevOps Kit that picks up changes or, changes or malicious configurations. Maybe I've got a secondary tool that checks the values in these Logic apps and says, well, if you don't find this API over here, tell me, I would like an alert, please. So it's really about just looking and seeing, well, what flows have I got, and how can I compensate for those flows? And that's the high level of threat modeling. So security features, products, and advice. I really love this picture. I don't know. I honestly have no idea how the media came up with this one. There's so many questions, like why is there a lock on a laptop, and why is someone trying to type with boxing gloves on? But that's how the industry works, I suppose. That's how the cyber criminals are viewed these days. So before we dig too deep into that, let's talk about general Azure security. So in Azure, there is a set of core services, and I pulled these out of Visio in about 10 minutes, that actually enable your business to stay secure. They are not integration specific. They are just general services that really, really do help to harden your environment should you have a need. So a lot of Probably the most important ones for me are the identity-based ones. So if you're looking at Azure AD identity protection, privileged identity manager, conditional access, there's others out there that really prevent people from, behaving maliciously inside of your Azure environment. So I talked before in the threat model about someone logging into your Azure portal and seeing, insecure data and going from there. So you could look at conditional access to say, well, you can't log into my Azure portal without MFA, so they have to steal someone's phone to log in, or use identity protection to say you can't log in from the Ukraine, right? The other ones, you've got activity log, Azure Sentinel, which really are focused on a lot of audit. So Azure Sentinel is their cloud SIEM, and incident response, and activity log is your immutable store of things that go on in your Azure portal, so you can really see what's happening. You've got Azure Policy, which will allow you to enforce secure behaviors in your environment. So maybe you don't want your users to deploy SQL. You can disable that. Maybe you want, encryption turned on, or maybe you want to disable HTTP on your Azure function. You can do that using Azure Policy. And then you've got other services like the network-based ones, firewall, application gateway, and then Key Vault for data storage. These are just high level. Like there's another 20 or 30 things I can dig into based on the different areas, right? I would really recommend you go to this link here, which is it's actually the Azure Cybersecurity Reference Architecture. It's developed by Mark Sinos. There's also another list, Mark's list, which I'll distribute with the slides. Really good references for general Azure security. All right, moving on. Before we start, I'm going to talk about Azure Security Center. Now, if you don't have this enabled in prod, take a quick pause, go turn it on. It basically is a service that is free for the majority of users, and it has a paid tier as well that's quite good. This screenshot on my screen right here is actually taken from my Azure environment. So I've got a lab that I've set up, and I've got an Azure Security Center on the free tier because it's a lab and I don't really want to pay extra money. But I'm getting recommendations at any given point in time on how I can make my own security better. Now, this covers everything. It covers from IaaS to IoT. If you've got app services functions, it will make recommendations across the board, and you can go really deep on it. Now, one of the things I really like and is really good for a lot of teams to adopt is the secure score, because it gamifies your security response. You can look at the security and say, oh, that's getting better or worse. And it actually gives you a metric that you can take back to your management and say, hey, I'm improving security in my environment. So yeah, that one it's like I said, turn it on now if you've got it in your environment. All right. Ooh, there you go. Fancy slide. So deployment security. Now, I touched on it briefly a little bit earlier around understanding the flow of where your data is coming from and to, right? So in your environment, in my earlier threat model, I had Azure DevOps. Now, Azure DevOps is your friend for security. It actually gives you a really, really powerful way to manage your environment. So you have source control, which really enables easy rollback. So if something goes wrong, you can pull it back. If something's not working in, for example, Melbourne, just for argument's sake, say the service goes down in Melbourne and you don't have it spun up anywhere, it's actually quite easy to change a pipeline and push it into another region. So you've got, business continuity and disaster planning. So maybe someone logs into your Azure portal and they've just got a malicious intent to make your life hard as a business. You can use it and they go and delete your entire environment. Now, Microsoft would probably be pretty helpful in this scenario, but if you have a requirement to get things up really quickly, you can just go into Azure DevOps and do another release, or maybe you can push it into a different region, or there's a bunch of different ways to just bring things up. It's got built-in auditings, which is really, really good as well. And a properly configured deployment pipeline will really minimize your administrative access. So I've worked in a couple of environments now where this is being seriously considered, and some where it's been implemented to amazing successes. What you can actually do is you can set up your prod environment so that no one has write access to it. So you have service principals only that push into prod. No one can log into prod and change settings. They can log in and see the settings, but they can't change them without pushing through an Azure DevOps pipeline. And if you configure that, really, really well, you can have that that commit go into dev and then push all the way through, you know, sit, UAT, whatever environment you want, and then into prod. In terms of Azure DevOps, there's a wealth of tools online, and I really recommend the Azure Secure DevOps Kit. So that's AZSK at the link below. And that's a tool that actually allows you to validate continuous compliance. So you can install an automation account in your environment, and it'll tell you that security issues when they're popping up, when they're going away, are they coming back. It also allows you to do things like validate your ARM templates. So if you're deploying using ARM, it'll tell you, hey, you just deployed this service and it's got a security configuration out of the box. You can break your builds using that, which is really quite useful. All right, API management. So API management's, honestly, it's an absolute powerful, really, really powerful tool. And it's not to be confused with API Gateway, which is the AWS equivalent, even though it has Gateway in it. So it has three core functions. It allows you as an administrator to manage your APIs. It allows your APIs to be front-ended by a service. And it also has a developer portal. So you can log in and see, how does this API work and why does it work like this? You can deploy this on-prem, cross-cloud and in Azure. So it actually supports running in a container, and you can push it across cloud. It allows you to simplify authentication for all your APIs. So for example, maybe you've set up Tom with a login to one API. You can then apply that account and that subscription across 5 different APIs, and there's no issues. So it's, by bringing it into one location, it makes your authentication really, really simple. It's got really, really deep policy enforcement. So you can do header removal, header addition, modification. You can do IP whitelisting and blacklisting. You can rate limit users. There's a really, really diverse range of policy sets, and you could do a whole talk on it. And you can integrate it into virtual networks. So it's a really, really powerful tool. I personally like the developer portal quite well, because one of the things for security that's really important is actually identifying your assets. So the developer portal, if it's configured right and your developers are using it, enables a security team to come in and say, oh, I've got these information assets and 4 of them are presented to the internet and they've got these controls on them, right? So it's really quite useful. This is not an integration technology, but I feel like it should be covered because it's just so common. So a lot of companies now are putting Azure SQL into Azure, or they're looking at using other services like Cosmos or table storage, whatever it is. If you are putting SQL into Azure, please pay the $20 a month and put advanced SQL Server threat protection on it. So that comes with a couple of things. It comes with advanced threat protection, and you can see there in the screenshot, that's me testing out some demos around SQL injection. So it'll pick up malicious attacks there. All of the Azure SQL by default has transparent data encryption turned on. So that one's not such a big one. You've also got data masking, so you can mask data from the Azure portal in terms of, if maybe you've got credit cards in your environment, you can mask those rows. And then there's also a vulnerability assessment solution, which will find vulnerabilities in your SQL setup. Logic Apps has a couple of really useful controls. So you can do whitelisting. So you can, on a Logic App, set up whitelisting both on the Azure portal with the runner history, or the actual endpoint itself. Now, I will go through this in a bit, but what you can do is you can actually set the Logic App to only accept requests from the API management. So in that scenario, you've just limited your request a little bit to say, well, only you can access this only on these scenarios. It's got data masking built into it as well. So perhaps you're receiving a certificate, or you're getting a certificate, or you've got credit card information that you're pushing through the service. You can mask that in flight as well. I wouldn't recommend pushing credit card information through, but that's each to their own. And then on the right-hand side, we've got managed identity. So Logic Apps authenticates and connects to a large amount of services inside of the Azure platform. You can use a managed identity to make that really simple. You don't have to type a username and password, and it's all it's all secure. It's quite powerful. In terms of built-in security features, nearly all of the products provide the following or similar features. There's VNet integration and service endpoints, and that's network-based security. All of them have got end-to-end encryption. You can obviously turn on HTTP and HTTP, turn on or off HTTP, and nearly all of them support SaaS authentication at a minimum. Now, Event Grid and Service Bus have got a nice grid you can go and have a look and say, well, this feature is turned on, this feature is not, and that's quite useful. So, I understand I've covered a fair bit, and I've kind of been very broad in my talk. So I figured we're going to focus a little bit here on the threats I discussed earlier in the threat model and look at how I could secure issues. So this is a screenshot from my browser on the Donut website. So you can see here that that Donut website takes orders. The user can submit a quantity and say, I'd like 10 to come through. And that will cost them, whatever it is, $10.12. Quite simple ordering process. So without too much fuss, we'll push through to that. Hey, Bill, just checking you can see my browser.
Yep, just fine.
Perfect, just checking that there. All right, so as I said in the PowerPoint, we've got a website that's up and it allows us to order donuts. Right? Now this donut website is quite simple in that it just takes API requests with a request and responds back with an order number, and then separately processes the request for donut payment. So it says, hey, you owe me $5 for those donuts. Thank you very much. Now, the hackers had a look at this website and they've started to look at how it's configured. They've inspected in their browser. They've gone and said, I'd like to inspect this, and they've looked at all the traffic and they've seen that you're calling an API. And this API is an Azure Logic app. Is a basic Azure Logic app, and it's really very secure at all. So this is what it looks like. Now, this is really badly written Logic app, so I would not be deploying this into prod, but for demonstration purposes, it works really, really well. And they've come in and they said, hey, I'd like to call this API. Here's my URL. Body, and I'm just going to say raw. Bear with me. So they found this API by inspecting the website, and they'd like to call it and send through a request. Not bad. And they get an error. That's not supposed to happen. I love when demos go really well. So let's have a look. Oh, yeah. Just mess this quickly. Let's try again. Doesn't want to play nice. This is going to go really well as a demo if this doesn't play nice. Bear with me, guys. Timer cream donut. Yep. There we go. Okay. So Postman's not playing nice for some reason. So I'm not going to bother around with that, and we'll just use global integration. We're going to use the API management service to make those requests for now. So inside of API management, I've said, hey, I'd like to order a donut. I'm Homer. I want a cream one, and I want 12 of them, right? And my API said, hey, well done. You've got an order. I've accepted it. Here's your order ID. So on my website now, I've got an order ID, and it says you've got, 13 donuts. Now, if I'm a malicious actor, what I can do there is I can look at I can look at that traffic and go, oh, okay, that seems really good. I've got 3 fields. I've got Homer, cream, and 12. What if I send something, that's not so nice, right? And maybe I think there's a bit of SQL behind this API. Now, I'm as a malicious actor, I'm guessing. Right? I don't know that there's something behind this API, but I think I have a really strong suspicion due to other reasons that there's something there that's SQL. So I say, all right, well, I need to figure that out. So first things first, I'm going to do a very, very basic SQL attack where I've basically added in a quote. I've added steps after my final quote. So I've actually closed out the SQL there in my variable and then said, I want you to wait for 20 seconds. So what I should see here is if I make this request, it should take a while. It'll take 20 seconds. And I go, oh, okay, I've just found some SQL and I think it's vulnerable. I'll move that so we don't switch screens. And I really think I've got a chance of getting in to the service here. Now, there's tools these days that will that'll do this process and they'll do it very, very well. They will do it automatically. So as a malicious entity, I realized I can put something in here that's not very nice, and I can start to tinker around. Now, this type of attack that I'm doing right now is referred to as blind injection. So I don't know that I'm going to get a response back, right? Because I'm pushing something into the API and I'm not really sure what it is, right? So I can have a look and say, well, can I find oh wait, that's the wrong one. Yeah. Can I find a table, right? So I'd like to figure out what the table structure of the SQL looks like. So in this scenario, what I'm saying is, I know that my username from the website is Homer, right? And I'm saying if 1 equals this, and then I do a very, very specific statement that should only ever equal 0 or 1. So I'm saying, I would like to go and try something, and I'd like to see if the usernames table exists here. And I will run this query. And because I've kind of in my API set up some error handling, I've got a problem. I've said I've got an internal error and I've basically been told to try again. I go, oh, okay. I'm going to keep going with this. Maybe I'll just keep guessing. All right, I'm going to try again. I'm very, very, very patient attacker. I'm looking at it going, oh, that doesn't work. Still really struggling with just, getting into the service. I'm going to try there. Takes a bit longer this time. That's a bit strange. And then I get to the other side of this request and I still get a failure, but I will get a different one, right? As an attacker, I can look at that and say, well, my time to complete the request is taking longer, so something different is happening. Now what I can do, so I can actually see that in the API, in our logic app. So these are the 2 that I tried to make work and they didn't work. And you'll see here, I've received a request. I've called the database for SQL, and then it says invalid, right? And I'm returning the error here, right? So I've tried to do the right thing in the logic app and return error as well. But it's something, there's still information to be gleaned from this as an attacker using blind injection. I look at this one, same thing. I've returned out the response here. When I look to this one, this query has succeeded and it's taking a bit longer. Now I'm breaking the SQL here further into the thing and that will retry 4 times by default. But basically I've pushed through some malicious SQL And I know as a, as an attacker that taking too long is something that I care about. So, okay, I think I've just guessed a table. So I note that down. I say the users are kept in the users table. And I've definitely got a username property because I'm selecting out values there. What can I guess in terms of other tables? So I keep going, all right? And I have a look again and I paste in some more SQL. And basically the trick with the SQL is to convince it to do something else. So you know that it's going to ask and look for a user named Homer, you think, and then you want to add something on the end to say, hey, I'd like to maybe look for the purchases here, right? So I'm looking for a cost table because I know that I'm ordering donuts using this API. And I push through and I'm going to get a failure for that one. And I keep trying and I go all the way and I eventually figure out that I've got a orders table. Okay, that's really cool because I know from I should have an orders table. No, actually, no, that's correct. Yeah, so I've got an issue with the user. That's good. Yeah, so I know that I've got a different order now, a different issue from before. So before, when I was putting in a table, I was getting an issue with the API, and now I'm getting an issue with the user. I can have a look at this again. Now you'll notice a lot of failures here. This is the one I said where I'm guessing the orders table. So I said, can I find the orders? And I've got a different response. So the response for this is issue with the user, and the response up here is, if it was to display, is internal server error. No, there we go. Well, please try again. So it's a 500 saying I've got an internal server and I need to try again. Whereas this one is issue with the user. Now, as an attacker, I'll look at that and say they're completely different things. So it means I've done something different. So keep digging through. I've looked, I've been able to figure out that I've got a users table. I've got an orders table, which is exactly what's in my SQL structure right at the moment. I can show you that. So this is my SQL, and this is what the database actually looks like. So I've got a users, donuts, orders, and payments table. Now, I've been able to guess through intelligent querying and assuming things that I've got an orders table and I've got a users table. I don't know that a donuts table exists, and I don't know that a payments table exists. But the process I use to figure out those tables, there's multiple different ways to do it, and I can push through for a large amount of different combinations. I will be able to eventually, through sheer willpower, figure out what those tables like if this vulnerability keeps sitting in the database. So we're going to assume that the hacker has worked out that they have a users table, a purchases table, a donuts table, and a payments table. So maybe I've worked out I've got a table, and now I need to work out what the columns in that table look like. Right? So I can do the same thing over and over again, just constantly hammer this API and just have, I'm really, really patient, push through. Sorry, I've copied instead of pasting. All right, and I can push through and I can find columns now. So now I'm going and saying, I still have a really very specific query. I'm saying I should only get one result from this. Right? And if I don't get one result, then I'm concerned. And I say I'm looking for a column where the table is the orders table because I found that already, and I'm guessing the quantity. Right? I could have anything in here. I could have, I'm guessing for amount. I'm guessing for order size. I can guess for all of those and just keep going, right? And I'm making educated guesses based on what I've seen in my website. So I know in the web portal that I had a table that said I've got donut orders for Tuesday on these sizes, and I keep pushing through. And again, I get a slower response, but I know that that's indication to me, I can assume that that's an indication of this flow and not this flow, because this flow was really quick. Okay, so I've gone through and I've guessed a real huge amount of data. I've been really patient. It might have taken me a week or so. And I think I know what the database looks like because I've guessed a lot, right? Now, through trial and error, when this comes back to me, I can start to look at doing stuff like adding donuts or adding free donut orders, or adding in nasty donut recipes. So once this comes back to us, we'll go forward with that.
Hey, James, you got about 5 minutes at most.
Cool, that's fine. All right, test. There we go. Paste back in our request. There we go. All right, so now I've figured out I'd like some, I've worked out the schema, and I said, oh, now I really want some donuts. And I've pushed in and I've said, okay, I want to add in a nasty donut and I want this many of them. And that's my order ID because I get one of those for everything. And my name's Homer, so I have a Homer donut order. I click send, and that will take to get some time again, and I get a donut order, right? Maybe I want those nasty donuts to be free, right? And I've spent the last week and a half working out this schema, so I know all the important bits of the table. And I've said, hey, I would like some free donuts. Right. So you can see here, I'm saying I want you to add a payment. I want it to be amount, and I want it to be processed. So I've said it must be one. I'm pushing through and I'm sending that through, and that's going to take some time. And all of a sudden, even though I've got a please try again, I've got some free donuts. Right. So how do you handle that, right? How do you push through, or how do you make sure that your application is secure? So the key thing is to think at every point, every step you add. So if you're in the Logic Apps Designer and you're adding in a step, if I do this, what can go wrong? Right? So I look at this, this flow, and I go, okay, well, I'm calling the SQL database. So perhaps I can come in here and I can parameterize a query. So rather than add a SQL step, which is very, very lazy of me to do it like that, I can add a stored procedure and then add in different steps. Maybe I can validate this field before I receive it. Maybe it's too long, too short, that sort of scenario. There's also tools out there that will actually tell you what's going on in your environment. So I've been doing some fairly common SQL injection. So I'll actually have emails in my inbox right now for SQL injection, right? And this occurs in my environment. So when I talked before about the Azure SQL threat protection, this is something you can turn on as well. And you can look and say, well, rather than stop the attack, or I'd prefer to stop the attack, but if I don't stop it, I'm going to pick it up and we're going to go from there. So you can see here, it says, where it was. I've got really bad internet apparently. And then if I go here, I can actually start to say, well, I would like to call this API of this Logic app to fix it. It tells me what I was doing. So I was actually trying to figure out, right, this query. I was trying to figure out what was in this what was in the tables, right? I can play around with that and fire off alerts. The other options I have is I can start to look at saying, well, maybe I've picked up the SQL, I've picked up the, I've parameterized my Logic app. Maybe I can go down and say, well, why was he able to call this API directly? Right? I can come in here and go workflow settings, and I can say, oh, I can limit that, right? So I can come back and I can go to my API management service. I can take the IP of the API management, and then I can go back to my Logic app and add in this IP. So I can say you're only allowed to speak to me from here. I don't want that. The only place it's allowed to talk to the Logic app or to my API is the gateway, right? And then you push everything through the gateway, and okay, everything's going through the gateway now. Maybe I add in a secret as well. So I've come in, I'll create a user, and I'll add in a user here, and then I'll add that user to a subscription, and that user is subscribed to the Donut API. In that scenario where I've got the injection happening, I've gone and put in a parameterized query. I've gone and put in a API management service to actually sit in front of the gateway. I've restricted access to it. I haven't designed nasty Logic apps in the first place because I've done a threat model and I've actually understood, this could happen in my environment. And I've turned on after the fact alerting to something going wrong. So I've actually got the SQL threat protection saying, hey, you've actually had an issue in your environment. You should probably go look at that. that's the best way to secure your API, to your Azure integrations. Start from your deployment, work through all the things that could go wrong, and then work through the compensating controls. So understand, hey, I'm vulnerable to SQL injection. What do I do to stop that? Hey, my users can log into my environment without credentials. What do I do to stop that? If you keep doing that across your entire environment, you will end up with a really, really quite secure Azure integration. And with that, that's the end of my talk. Hopefully there's some questions. I understand I did fly through a lot of things. So yeah, fire away if there is any.
There's no questions at the moment. We might be able to pick those up a little bit later too if people come up with questions. So because we need to get the next talk started.
Perfect. Let's do that then.
Okay. Thank you very much, James. And I will be shutting this one down and starting up the